The pros and cons of hydroelectric power. Hydroelectric power is a highly popular form of renewable energy around the world. It is a clean source of energy that has been being used for centuries and is still widely used today. The technology harnesses the kinetic energy of falling water to generate electricity. However, like any other power source, hydroelectric power also has certain advantages and disadvantages. In this article, we'll explore the pros and cons of hydroelectric power to help you understand this source of energy more deeply. Pros of hydroelectric power. 1. Renewable energy. Hydroelectric power is sourced from flowing water, and water is considered to be a renewable source of energy. As long as the water supply is being maintained, the production of hydroelectric power is continuous and sustainable. 2. Clean energy. Hydroelectric power is considered to be one of the cleanest sources of energy. It produces no pollutants or greenhouse gases and does not contribute to climate change. This makes it the most environmentally friendly source of energy. 3. Cost-effective. Hydroelectric power is a cost-effective source of power. Operating costs for a hydroelectric plant are quite low, as the water can provide constant energy for free. Once the plant has been constructed, maintenance costs are low in comparison to other sources of energy. 4. Flexibility. Hydroelectric power is highly flexible in that it can be quickly ramped up or down to meet the fluctuating demand for electricity. This flexibility is due to the ability to turn generator units on and off easily. 5. Multi-purpose use. In addition to producing power, hydroelectric plants can also be used for other purposes, such as irrigation of farmlands and recreational activities, such as canoeing and fishing. Cons of hydroelectric power. Despite the advantages listed above, hydroelectric power still has certain disadvantages that should be taken into consideration before opting for this source of energy. 1. Expensive to build. Although it is cost-effective to operate, hydroelectric plants can be quite expensive to build. This is because building a hydroelectric plant involves the construction of major infrastructure such as dams, generators, and transmission lines. As a result, it requires a significant initial investment before the plant can be operational. 2. Dependence on water supply. Hydroelectric power depends on a reliable supply of water. If the water supply is disrupted, it can have a significant impact on power generation. This can be due to droughts, lower rainfall, or melting snow, which can slow down the water supply and reduce its flow to the generators. Additionally, hydroelectric power needs a significant volume of water in reservoirs and dams to ensure constant energy generation. It is not uncommon to observe fluctuations in power generation due to changes in water levels. 3. Impact on environment. Additionally, the necessary building work can lead to deforestation, a major source of Earth's carbon dioxide emissions, as forests are cleared for construction sites. 4. Disruption of natural ecosystems. The construction of dams can have an impact on natural ecosystems as it results in an altered flow of water. The installation of dams alters the natural flow of rivers and can lead to a decrease in availability of water downstream of the river. This can impact the growth of plants, the health of fish, and populations of wildlife that rely on the flow for sustenance. 5. Safety concerns. Hydroelectric power has certain safety concerns that must be considered. For instance, the dam that is necessary for the generation of hydroelectric power can pose significant safety and maintenance issues. In addition, water that is discharged from hydroelectric plants can cause flooding downstream, which can result in significant property damage and loss of life. Additionally, efforts have been made to minimize the impact on the environment and natural ecosystems by designing dams and hydropower plants with the environment in mind. As for the cost of hydroelectric power, advancements in technology have helped to reduce the expense of construction and maintenance. The use of smaller-scale hydroelectric plants, such as run-of-river systems, which do not require a dam, have become more common and cost-effective. Additionally, the use of new materials and advances in turbine technology have allowed for more efficient and cost-effective energy production. Despite its drawbacks, hydroelectric power remains a vital source of renewable energy, particularly in countries with access to large water resources. In fact, according to the International Energy Agency, hydropower is the largest source of renewable electricity generation worldwide, accounting for 63% of total renewable electricity in 2019. Furthermore, it is projected that hydropower will continue to play a significant role in meeting the growing global demand for electricity, particularly in developing countries. In addition to the efforts to improve the safety and environmental impact of hydroelectric power, there are also ongoing research and development efforts to enhance its efficiency and effectiveness. For example, new designs for turbines and generator units are being developed to improve their efficiency and reduce maintenance costs. Advances in material science have also led to the introduction of new materials that are more durable and can withstand the harsh conditions of hydroelectric power generation. Another area of research is the exploration of new ways to generate hydroelectric power. One promising area is the use of tidal power, which harnesses the kinetic energy of tidal currents to generate electricity. Tidal power has the potential to be a highly efficient and reliable source of renewable energy, particularly in coastal regions. However, it is still in the early stages of development and requires further research and investment. Furthermore, there is also growing interest in the use of pumped hydropower storage. This technology involves using excess energy from other power sources, such as wind or solar, to pump water to an elevated reservoir. The water is then released to generate electricity during periods of peak demand. This method has the potential to increase the flexibility and reliability of renewable energy sources, such as wind and solar, by providing a means of storing excess energy for later use. Finally, there is also a need for continued investment in the infrastructure and maintenance of existing hydroelectric power plants. As these plants age, they require repairs and upgrades to maintain their efficiency and safety. Continued investment in these plants is critical to ensure their long-term viability as a source of renewable energy. Moreover, the use of hydroelectric power can also help in reducing our carbon footprint and mitigating climate change. In fact, according to the U.S. Department of Energy, the use of hydroelectric power has helped prevent the emission of more than 10 billion tons of carbon dioxide since its inception. This reduction in greenhouse gas emissions can have a significant impact on our environment and help in slowing the pace of global warming. Furthermore, hydroelectric power can also play a critical role in developing countries where access to electricity is limited. In many remote regions, communities rely on diesel generators or kerosene E-lamps for lighting and electricity. These sources of energy are expensive, inefficient, and contribute to air pollution and carbon emissions. By investing in hydropower infrastructure, these communities can gain access to a clean, reliable, and affordable source of energy that can help improve their quality of life.